Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Okay, write an equation showing, so this would be the last example. So write an equation showing the hydration of trans 3-methyl to pentane. Okay, so you should first draw the trans 3-methyl to pentane. So you have a carbon to carbon double bond. So you have CH3, CH3. So 1, 2, 3. So you have a methyl also here. So you have a methyl, and they are actually trans to each other. Okay, so 1, 2, 3. Then you have CH2, 4. Then you have CH3. And that would be 5. Okay? You have CH2, CH3. So 1, 2, 3, 4, and 5. That is 2 pentane. And they're actually trans. See, both of these CH3 are actually trans. Then that's trans 3-methyl. 1, 2, 3. 3-methyl. 2 pentane. Okay? Plus HOH. So it's hydration with the presence of your acid catalyst. So the major product will form so they are unsymmetrical. So the major product will form the Markovnikovs rule. So this carbon, it has actually hydrogen. That carbon has no hydrogen. So therefore, this carbon here would have more hydrogen than that carbon. So therefore, the hydrogen will be added there. So a hydrogen will be added there. And your OH would have to be there. So that would now be your major product. So the major product would be, you have CH3, CH2, okay, CH2, then you have C, okay, C, okay, that is carbon number 3, that is actually CH3, and the OH would be there, okay, the OH would be there, then you have your carbon, would be added with the H, okay, then you have your CH3, and you have your H, okay. So this would now be your major product. So this is now the major product. Major product. So that would now be the major product. And the minor product would be, the OH would be there, and the H would be there. Okay? That would be the minor product. CH3, CH2. Your C would be attached with H. Then you have your CH3 as the substituent. There's no space. Then that carbon number 2 would be attached with your OH. Then you have your CH3. Then you have your H. Okay. So this would now be your minor product. That is now the minor product. So both of these are actually the products of that. So, but this first product is actually the major product. So you'd expect that on the solution, this actually has higher percentage than this one. Okay, so both of them are the products for this reaction. Okay, let's move on to our last topic for the reactions involving alkenes. We have hydrohalogenation. So when we say hydrohalogenation, it's actually addition of hydrogen halide or HX to alkene to give a product which is actually an alkyl halide. Okay, so the general formula would be, if you have an alkene, then you're going to add an hydrogen halide. So that hydrogen would be added to that carbon, and that halogen would also be added to that carbon. Okay, so that you can form an alkyl halide. So there is actually no catalyst for this reaction because it's also very reactive. Your hydrogen halide are also reactive enough to to react with your alkene. Okay, so this is actually true for symmetrical alkene also. Okay, so if this is symmetrical alkene, then you would expect to have one product. If there is if the alkene is unsymmetrical, then same you would expect to have two products, which are actually a major product and a minor product. Okay, like for example, if you have ethene, which is a symmetrical alkene, if you are going to add this with hydrogen bromide, then that hydrogen will be bonded to that carbon, and your Br will also be bonded to that carbon, and the carbon to carbon double bonds will also be broken down to form a carbon to carbon single bond. Then you would expect to have an alkyl halide, which is actually a bromoethane. Okay, so you have ethane plus hydrogen bromide will form a bromoethane. However, is for unsymmetrical alkene, of course, it will also follow the Markovnikovs rule or Markovnikovs principle, just like your hydration of alkenes. Okay, so it's different because for hydration, you're actually adding H and OH, while for Markovnikovs rule for hydrohalogenation, you're actually adding hydrogen and the halogen. Okay, so for example, if you have propene, so this is structure of propene. Then you're going to add hydrogen bromide. Okay? So you expect Markovnikov's rule that the carbon with the more hydrogen would be added with another hydrogen. So in this case, this carbon contains two hydrogen, but that carbon contains only one hydrogen. Okay? So therefore, this carbon would have uh, more hydrogen, then it would be added with another hydrogen because you know the principle, the rich will become richer. And the Br would be added to that carbon. So if it follows the Markovnikov's rule, then that would be the major product. So in this case, you notice that that carbon would be added with another hydrogen, and that carbon is actually added with the Br. So this is now your major product. However, you can also form that this Br will be added there while that hydrogen would be added to that second carbon to form the minor product. Okay, the Br is now on the first carbon and the hydrogen is actually on the second carbon. So you can either form a 2-bromopropane. This is a 2-bromo. You have 1, 2, 3. So you have 2-bromopropane, which is actually the major product. And you can also form 1-bromopropane, which is actually the minor product. Okay, so for unsymmetrical alkene, you should follow the Markovnikov's rule. So for example, write an equation showing the reaction of 1 pentane with HCl. Okay, so 1 pentane, you would expect that it's a 5 carbon, CH2, we have CH2 also, we have C double bond C, okay, so be hydrogen, and you have also hydrogen, and you have hydrogen here, it's hydrogen. So 1, 2, 3, 4, 5, so this is already 1 pentane plus HCl. So you notice that 1 pentane is actually unsymmetrical. So to get the product, so if you have unsymmetrical, then you have your major product and a minor product. So the major product will follow the Markovnikov's rule so that this carbon, this actually contains two hydrogen and that carbon contains only one hydrogen. So therefore, this hydrogen would be added there to form the major product and the Cl would be added there. So that you will have a product which is actually a 2-chloropentane. CH2, then CH2. Okay, then you have hydrogens. Then you have your Cl on the second carbon. Then you have your carbon there, which is actually added with another hydrogen. Okay, so this is now your major product. Okay, so the minor product would be your chlorine would be bonded to that first carbon and the hydrogen would be bonded to the second carbon. Okay, CH3, you have CH2, CH2, then you have C, H, then you have your H, then you have your H there, and H, then you have your Cl. Okay, so this is now your minor product. So what is the name for the major product? You have your 2-chloropentane, and the minor product is 1-chloropentane. Okay, so that's it. So these are actually the lessons for reactions involving alkenes. So that is the last part for the lessons for alkenes. So hope you learned something and you'll be able to answer the questions or the exercises that will be given to you later. Thank you.